Hello everyone, welcome back to another video in our third unit on EDA. If you came from the previous video, you know that this video was actually recorded in one piece and then split into two parts. So I'm just recording a quick intro for this video before we get into the content. So thanks for watching, let's get into it. So like usual, I have a couple sample exercises here. So I actually don't have a requirements file or an initialization notebook yet. I want to show you how to update to the latest version of Altair, or maybe not the latest. I think I'm going to do 5.0.0. And I'm going to do it in a way that DeepNote's not too happy about, but I'll show you kind of what to do. So I'm going to say pip install, and I want Altair. I want 5.0.0 RC1, and I'll run this, and okay, this is looking fine, but now DeepNote is saying delete this cell and move package to requirements text. I'm going to click here. So that looks good. Now I'm going to open the user interface, and we can see here now there's a requirements.txt file. So this is the Altair version that I want. Then notice now there's this hidden notebook, or it's like kind of it's slightly lighter than the notebook one. This is an initialization notebook. Basically, every time I run this notebook one, it's going to run this code, and it's basically just making sure the packages that I want installed get installed. So we don't need to mess with it. Basically, that's how you can set up an initialization notebook or requirements file. It's very useful, and now I don't have to worry about updating Altair at all. This will become relevant soon because in Altair version 5, some of the syntax is different than in previous versions, so I'll show you where those differences are. So now let's import Altair as alt. And let's check the version using the Dunder attribute version. So I'll say alt.__version. And we can see here, this is the exact version that we want. Next, it's saying, okay, so we're going to load up our data set. I think I already have it in this notebook, but let's do it again for good measure. I'm going to import Seaborn as SNS. And then I'm going to say df equals sns.load dataset miles per gallon. And for this first part, we're going to find the sub data frame for which the names of the cars contains the substring Skylark. And we're going to name this sub data frame, as you might expect, df_sub. And just as a reminder, I can look at the first 4 rows using head and then specifying 4. And I can see already here there's Skylark appears in this row, so we know it shows up at least once. And what I'm going to do first is make a mistake. So see if you can figure out what's wrong with this. So remember, I want the name to contain Skylark, so I can say df of name dot contains, and now I can say Skylark, but this is going to throw an error. So it's saying series object has no attribute contains. So remember, contains is a method belonging to string objects. So I need to access kind of string methods by using the string accessor. So if I do this, it returns a Boolean series that tells me false everywhere name does not contain Skylark, true everywhere else. So this is looking good. And now remember, we want to get the sub data frame. So we can do that by saying df_sub equals df of, and now we pass our Boolean series. And let's take a look at df_sub. Now, if we did this right, if I go to the name column, every row should contain Skylark. Notice there's only 4 data points that contain this substring, and this is looking good so far. Next part is saying make a scatter plot in Altair from this sub data frame using the model year for both the x coordinate and the color, and using miles per gallon for the y coordinate. And then we'll increase the points, remove 0 from the x-axis. We'll make it look nice, but I'm going to start by making just kind of a skeleton of the chart. So as a reminder, I'm going to do alt.chart df. Now I want this to be a scatter plot, so I'm going to use mark_circle, then .encode. I want the x-axis to have weight. Oops, that's not what I want. I want model year, for the x-axis. So this is going to be model_year. For the y-axis, I want miles per gallon. And for the color, what do I want? I also want miles per gallon. Oh, sorry, model year, sorry. So let's see. And what did I do here? So this is looking a lot bigger than I expected. This should be sub df, right? Or df underscore sub. All right, so remember there was only 4 points in that data set. This is really hard to see because notice there's 1, 2, 3, 4 dots. The colors are kind of hard for me to see unless I like really zoom in. So let's start by making this look a little bit better. The first thing I'm going to do is increase the size of the markers. So the way we do that is when we say mark circle, I can pass a size argument. So I can say size equals, and I know that 150 looks pretty nice. Otherwise, this is the kind of thing that you would tinker with, find what looks best to you. Okay, looking a little bit better, but there's still more things that we can do. So notice there's a lot of blank space between 0 and 70. So the model years start at 70, and everything in this space is blank. So let's tell Altair it doesn't need to start at 0 for the x-axis. Now, the way I'm going to do that is going to be using the new syntax. So I'm going to give the old syntax just in case you're not on an updated version of Altair, and hopefully that helps. So this is going to be old syntax, and I'll type it first and then we'll implement it. So the way you would do it is you say x equals. Now, if I'm going to specify anything about the x-axis, I'm going to call alt.x to say I want to deal with the x-axis. I want to access kind of properties of the x-axis. Then I say I want model year. And then I want to now set the scale. So I'm going to say, oops, and I'm doing the new syntax. Or no, this is good. Scale equals alt.scale. And then we say 0 equals false. So this is saying I don't need to start at 0. So that's the old syntax. Here's the new syntax. Notice that this one, I think it's a little bit nicer. So x equals alt.x. We still say model year, but now I go outside of the parentheses and I can now do dot scale and I can say 0 equals false. So I'm going to use the new syntax. Again, if you haven't updated Altair, try the old one or look at the documentation for the version that you're on. But now here, so I'm going to go to x, I'm going to say alt.x. Again, model year, now dot scale. And I'm going to say 0 equals false, meaning I don't need to start at the origin. So, okay, looking a little bit better. We still kind of have, I still don't think this looks too great, but at least now we don't have a huge amount of white space between kind of the origin and the first point. So kind of notice we have a data point all the way here on the left, and then 3 others. So, okay, next change I want to make is, well, what if we, let's see, so it's saying, what if you change different encoding types? So let's start by doing that. Model year, I think it makes sense for us to use quantitative encoding, right? Because we're not going to have like a fraction value of a year appear in this data set. So I can do something like, let's see. So here, model year, to specify the encoding. So think back to the table that I showed you at the beginning of this video. If I want ordinal encoding, I use O, and I think I don't remember what I just said. I might have said quantitative, I mean ordinal encoding, in case I misspoke. But ordinal, because I'm going to imagine these as integer values. And yeah. So we can see already, notice now the spacing between the x-axis has gone away. And not much else has changed, but already it's looking nice, right? It got more compressed because now we don't need to deal with these intermediate values. So, okay, that's looking pretty good. Another change that we could make is we could say, let's see, what do I want to do next? I think what I want to do, let's do some colors next. So I guess I really should have done this. Let me pull this exercise above. Oh boy, that wasn't good. Let me try one more time. All right, so here's the ordinal. Now, it's saying the difference is going to be more clear if you use a different color scheme. So if you click here, and here it is. So here we can see there's a whole bunch of different color options. So we really could be dealing with categorical scheme, but just for an example, like let's say I like these sequential single hue schemes, you can click here and view discrete and see how it changes the values for discrete values. So, okay, let's go back to our previous tab. All right, so now that we're back at our original tab, let's do some color encoding to see how the values change. Or not the values, but kind of like how the colors look different. So what I'm going to do is for ordinal data, let's specify color. So I'm going to just make a new cell, copy paste. And the way we specify color is very similar to how we change things along the x-axis. So alt.color, model year, and then I'm going to say, it's again scale, which is maybe a little bit strange. But then inside we say scheme equals, and let's try purples for instance. Oops, and let's see, oops, yes, this should be out here, dot scale. So again, this is with the ordinal data type. And I guess I should also specify here with the color as well. So let me show you this compared with, remember the default value is quantitative. So if I don't specify anything, that's what it's going to look like. So notice here we get this continuous color spectrum. And what I want to draw your attention to is these three values are all very close in color to each other, versus up here, they're more spaced out. So when we use ordinal encoding, the colors are evenly spaced out, versus with the quantitative encoding, these ones are much closer together. Hello everyone, me from the future here. I remember there was one more example I wanted to show in this video before really ending it. So again, we were talking about kind of the difference between ordinal versus quantitative encoding for this plot. And kind of notice for the ordinal encoding, it's making the colors look kind of, they're evenly spaced, right? What I wanted to show you though is what happens if we do a nominal encoding without specifying a color scheme. And the point of that is I just want to show you how Altair makes the colors look as distinct as possible. So I'm not going to specify a color scheme here. I'm just going to say that let's encode model year as a nominal value. So again, nothing's really stopping us from saying that the years are nominal, right? We can ignore any ordering on them. And I just wanted to show you here how the colors look pretty distinct. So I guess also there was kind of something else that I wanted to talk about. Not really sure the best place to fit it in terms of our video catalog, but like this one here, so we can see kind of the model here is on the x-axis. So in terms of accessibility, if these colors aren't easily distinguished by a viewer, we can also look along the x-axis and get the same information. But let's say that wasn't the case. Another way that we could do this chart is by encoding color and also marker shape. So let me show you what I mean by that. So I'm going to change our plot from mark circle to mark point. And what I'm going to do is, along with color, I'm going to specify something called, not scale, sorry, shape. And this is going to be model year as well. And I'm also going to specify that it's nominal. So what's happening here is it's picking a different shape for each year. So for instance, if we wanted to make our charts more accessible, the color and the shapes kind of represent same information, right? So kind of red represents the year 79, but so does triangle. Plus represents the year 81, so does green, this kind of thing. So again, just wanted to show you how to kind of use these shapes to improve your charts. For real, I think this is a good place to end the video. Thanks for watching, and I'll see you in the next one.